The op-amp is there, and you have a transistor. You have 1 kilo ohm resistance here. Beta for transistor is given 50, and this is connected directly to the ammeter. And the VCC is given plus 10 volt. And here you are applying 5 volt plus 5 volt through 1 kilo ohm resistance. Now the question asking current, to find the current IB, you have to calculate the base current IB. Okay, you have to calculate the base current IB. This current you have to find out. Okay, so how to approach this problem? Can anyone suggest me how to approach this problem? Manu, कैसे करें इसको? Vishnu? Okay, so we know from the properties of op-amp that the terminal voltage will be almost same. So if I say, because here no current is flowing, input terminals do not draw any current. So here no current is flowing. So this point is 5 volts. So obviously this will be also 5 volt. And this is the 5 volt. This 5 volt directly will come here. This is the collector, this is the ammeter. So this current become ammeter current. This become IE. So I know the 5 volt. This is the ammeter terminal voltage 5 volts. So I can directly find my IE is 5 volt divided by 1 kilo ohm, that is 5 milliamps. And I know my IE is almost equal to collector current. So this is 5 milliamp. Now beta is given, so I can find the base current. Base current is the IC by beta. Okay, so 5 milliamps divided by 50, 1 by 10. 10 raised to power minus 4 ampere, or you can say how much? 100?
0.1. 0.1 milliampere.
That is, you can say 0.1 milliampere. 0.1 milliampere. The answer is asking milliampere, otherwise it is 100 microampere. Okay. So answer is asked in the milliampere. So this will be 0.1 milliamps. Now let us solve the second problem. So anyone has doubt in this problem? So I am going to, if there is no doubt, I am going to solve another problem. You have been given a circuit here. You have a diode. This is the basically, and there is a load. You are applying plus here, minus here, and then minus is coming here or here. Here you are applying B input. So you have to find the transfer curve. Transfer curve means I want to find what will be the output here if I apply input. So basically I have to draw input output characteristics. Okay, so this is my output, and this is my input. Okay, so circuit is well known, is the precision rectifier, and the use of precision rectifier is to rectify small signals. Okay, a small signal means like if your signal is in millivolt, peak to peak voltage in millivolt or microvolt. Okay, or the voltage is less than the threshold voltage of diode, then you cannot use directly rectification. So we do using op amp. Okay, now tell me here, obviously some BCC, some value will be there. It's not given the question, but is this op amp always works as BCC. Okay, so suppose if I now there is a feedback, negative feedback. Okay, here is a negative feedback. The diode is there in the feedback. So if I remove this diode here, say there's no diode, I want to find where diode is in cutoff region, or diode is conducting or not conducting. So I want to check how much voltage should come here. Okay, so now if I open this one, what is the voltage in this terminal? What is the, I say this is a output of op amp. What is the value here? Tell me. Can anyone tell me what is the value here?
Is it BCC?
Yes, it is a VCC. Okay, because now this is the open loop, and whenever there is the open loop, okay, what happens in open loop? In open loop, the voltage always is equal to, because I am applying here, if it is the open, this is the ground. So this is the ground terminal. I am applying the non-terminal open loop, so it will saturate. So it will become VCC. VCC may 5 volt, 10 volt. So obviously, whenever I apply positive here, this is conducting. Okay, because the diode is like this, and now here this is the ground, and this has become now plus VCC. So this is conducting. Now depending on diode is ideal, okay, or constant voltage motor, we have to replace that by that battery. Okay. Now second thing, if I apply now, if V input is positive, if V input is negative, then the output will be here. So output will saturate to minus VCC. Minus VCC, so that means now this will not be conducting. This will not be conducting. If this not is conducting, that means this will be open. Okay, and if this will be open, then tell me, then this output will be 0, because here nothing will come. Okay, this is open. This is not when these terminal will be same only when there is a loop. Okay, now there is no loop, so this will be 0. So I can safely say for whenever it is a
सर एक
negative.
बार रिपीट करना ये
कौन सा वाला?
सर दोनों में कंफ्यूजन हो रही है
पहले मैंने यहाँ पे लगाया पॉजिटिव, VI is positive. If VI is positive, okay, then here this is ground. So I'm making open now. This is the ground. This is the ground, and here VOA is equal to plus VCC. That means this diode is conducting. Okay, so I can replace by either short circuit, or question में दे रखा है the voltage drop is VD, so I can replace by a voltage difference VD, or 0. If it is 0.7, I can replace it by 0.7. Okay, and then in the first case, this will be replaced by a battery, say VD, or I say VD equal to 0.7, say 0.7, it can be anything. Now this loop is complete. Now I know this volt and this volt is always same. So here voltage V output will be also V input. So in positive, so this input can be positive or negative both, either sine wave or anything, a square wave or anything. It can be positive, negative, not necessarily triangular wave. Okay, so this is a both thing, positive part and negative part both. So for positive part, this is conducting, so I can draw the IV characteristics like this. Whatever V input will come here, same will be V output. Okay, and for negative cycle, if I check the open circuit voltage, this comes from minus VCC, that is open, so that nothing will come, it will come 0. That is rectification, na? If I apply sine wave, if my V input is sine wave, my V output will come, this part will come as it is, okay, because this is directly connected to V naught, and negative part I will not get. Is a positive part. Okay, so this is the rectification for small things. Now, if you want to rectify any signal through the diode, suppose diode is 0.7 volt, then your input should be greater than 0.7 volt. But here we don't require that one. Here, suppose this is my 10 raised to power 4 amplification. Okay, and I want here the voltage greater than 0.7 volt. Okay, 0.7 volt. That is a VID into A. This is VOA, output of op-amp. And it is so VID, how much? 0.7 divided by 10 raised to power 4. That is around 70 microvolt. So even if I apply, the difference is 70 microvolt. Okay. Then also I can get here 0.7, and I can make this diode conducting. So basically, by connecting the diode here, we are reducing basically its threshold voltage, and this diode is called super diode. Okay. Now, so exam में sometimes they sometimes, so this voltage, you know, always this is VI. Suppose if I apply here 1 volt, so obviously this will be 1 volt. Okay, and what is this voltage? If this is 0.7, then this voltage will be 1.7 volt. This voltage will be 1.7 volt. This op-amp will always manage itself, or okay, so that this voltage, if it is 1 volt, this will be also 1 volt. But if this is a VD or 0.7 volt, okay, so this voltage should be greater than this one. Okay, so this is like this. So this is your precision op-amp. Okay, so let us go to the next question. What is the next question? Tell me. You have op-amp minus plus, this is the Zener diode, VJet. This is a 1 kilo ohm here, and this is 12 volt, and then you have here also resistance 1 kilo ohm, and this is your V naught R, and this is ground. Okay, so op-amp is given with Zener diode in the circuit. The value of resistance R in kilo ohm for obtaining regular output V naught equal to 0.9 volt is. So the output is given 9 volt here. You're asking what is the value of R. Okay, tell me कैसे करना है क्वेश्चन को. गौतम, अपर्णा, Ayan, how to approach this problem? हाँ अपर्णा, कैसे करना है? How to do?
So, if the means Zener is in reverse bias, then the voltage there will be constant, right? It will be equal to Vset.
So what is the voltage here?
Vset.
How much is given? VZ is how
Sir,
much?
4.7.
4.7. Okay. So 4.7. So first we have to see whether this diode is conducting or not conducting. So in order to check whether it is conducting or not conducting, the voltage should be greater than 4.7 volts. So I'll make it open. I'll measure the open terminal voltage. So obviously no current here, no current is flowing. So this voltage is here. So this voltage will make this diode conducting, and this will be conduct. Once this is conducting, it will behave like a battery of 4.7 volt. This is 4.7 volts. So this voltage is now 4.7 volt. So this voltage is also 4.7 volt. Okay, now you can find easily the value of R. So I can write now 0 minus 4.7, 0 minus 4.7 divided by R equal to 4.7 minus 9 divided by 1 kilo ohm. Okay, so my R will be minus, just 1 minute, V naught, okay, check it. How much is coming? Tell me what is the value?
1.093.
1.093 kilo ohm, huh?
Yes, sir.
Okay. So this is the correct answer for this question. You can check. I will send a solution. Okay, you can check it. Okay. अब कौन सा करना है? Question number 4. Okay, let us do question number 4 now. That is an easy question. Okay, you should be able to do it yourself. Okay. R2 is R1 is 3 kilo ohms, so you have a op amp plus minus V input here, V naught R1 R2 P. Okay, tell me what are the things here. R1 is 3 kilo ohm, R2 is 1 kilo ohm. R1 is 3 kilo ohm, R2 is 1 kilo ohm, and V input is 0.5 sin omega t. Okay, now what are the options are correct? Okay, so first option is given whether current in the R1 and current R2 is same. So obviously current in the R1 and current R2 is same, because here no current can go. I minus is 0. Terminal not carry current, so some current is coming here. Obviously that current will go here. Okay, so the option 1 is what? The current through R1 is equal to the current through R2 is correct. Option A is correct. Okay, option B, the potential at P is B naught R2 by R1. What is the potential here? Tell me. What is the potential here? Can anyone tell me what is the potential here?
The VI, V input.
V input. V input is equal to, and V input is equal.
0.5 sin omega t.
So and here the question is given R2 by R1. So R2 is 1, so it is not correct. Okay, so basically voltage, if I write in terms of R1 R2, this voltage will divide here and here. So if I want a VP, so VP will be what? V naught divided by this voltage divided by total resistance will be current R2 R1 plus R2 into R2. This is the correct expression. Okay, So this is the VP, and the VP which given the question is not this is equal to this one. Okay, and this is equal to obviously here VI 0.7 volt, but in terms of R1 R2 this is the value. So this B option is wrong. The amplitude of V naught is 2V. Okay, find out amplitude of V naught. V naught is 2V. So I can directly use this equation. Okay, and I can find, because the in non-inverting amplifier 1 plus R2 will come. So V naught will be R1 plus R2 upon R2 into V input. That is 1 plus R1 is how much? 1 kilo ohm, and this is
Sir, R1 is 3 and R2 is 1.
so 3 and 1, and this is 0.5 sine omega t. Okay, so this become how much? 4 into 2 sine omega t volts, and the amplitude is 2. Here is the 2 is the amplitude. So option C is correct. Amplitude is 2 volt.
Sir, but they are asking if it's 2 times V, right? Not 2
2
volt.
volt, no 2 volt,
Okay.
2 volt.
Okay.
Okay, and the output voltage V0 is in phase with VI. This option is correct or not? Option D, tell me.
It is correct.
Correct, no? Because this is a non-inverting terminal. So if it is a positive, this will come positive. If it is a negative, this will come negative. So this is always in phase. So option D is also correct.
And sir, again about option C, when they are asking amplitude means we don't need to consider the entire wave, right? Just
No,
the
no,
amplitude.
just amplitude. Question number 5. So here you have been given inverting configuration. You are giving plus V here. You have a C here, and you have a V naught here. Okay. What is the name of this circuit? Can anyone tell me?
Integrator.
Integrator. Okay, so this is an integrator circuit. An integrator, if the input is constant, then what will the output? Some integration is there with respect to t, and I say I'm applying some constant c dt. Then it will come home ct, some plus constant. So let us see that one. Okay, so this is R. What is the value here? R. Okay, so and this is ground. So let us write the equation, current equation here. Current equation will be a V minus 0 divided by R. And here voltage is how much? Current is capacitor current. I C dV. dV is here. Difference is here from 0 to, I'm moving from 0 to V naught. V naught dt. So C minus dV naught upon dt equal to V by R. So my V naught will be, tell me what is V naught? Integration V dt 1 upon RC minus, okay. And now V is constant. So this will come minus RC T, okay, and some constant C1. So which option is correct? Tell me.
Negative and linearly.
So option D. Okay, let us check option D is correct or not. Question number is what? 5th. D is correct. Let us do now question number 6. In the given circuit with an ideal op-amp, for what value of R1 to the output of the amplifier is V2 minus V1? Okay. So you are basically given a difference amplifier, minus plus you have R1, you have R2, you have V2, you have R, V1, this is also R, and V naught, and V naught is given V2 minus V1. V2 minus V1. Okay. Tell me the ratio of R1 by R2. So either you can apply superposition principle. Okay. So if I write V naught by superposition principle, what I'll do, I'll make it this 0. So my voltage will be minus RF upon R into V1. Okay. Plus, if I make this 0, if this makes 0, then output is here is V plus. Okay. So 1 plus RF upon R. B plus is what? Nothing. B2 upon R1 plus R2 into R2. Or you can write this voltage is here, same here, and you can apply KCL. Then also you can write this equation. Okay. Now my V naught is minus V1 plus 2 V2 R1 plus R2 into R2. Is there any value of V2? No. V2 minus V1. Okay. Now what is, now this is given is V2 minus V1. V naught is already given. V2 minus V1 minus V1 minus 2 V2.
Sir, it
Is
should be plus.
R2 R1 plus R2. Okay. So you can compare. So this is cancelled. Okay. V2 is cancelled. So basically now your R2 by R1 plus R2 should be 1 by 2. So this is 2R2 R1 plus R2. So R1 is R2, huh? R2. The ratio is 1. Is there option, any option? A.
Yes.
Let us check. Question number is what? 6. Question number 6. Option A is correct. Okay. Okay. Let us solve the question number 7. Question number 7 already we have done in the class. Okay, let us do it. Question 7 and 8 both we have done in the class. Do you want me to do this question 7 and 8?
Sir, please do 7 once.
Okay, 7. So question
So
number
what was the answer of the last?
1. Ratio is 1. A. Okay. So say an amplifier with a voltage gain of 40 dB without feedback is used in electronic signal. A negative feedback with friction connected to the input of the amplifier. The net gain of the amplifier in the circuit is closest to. So basically, open loop gain is given, and they are asking. So you have been given a open loop gain. OL is given 40 dB, and they're asking you the closed loop gain, and for that they have given beta is given 1 by 40, fraction is given 1 by 40. Okay, that's the question. Fraction is given 40.
Yes, sir.
Let us solve this problem. So I know the closed loop gain will be what? A closed loop gain will be
AOL by
AOL
1
by 1 plus
1 plus beta AOL.
beta AOL. Okay, so you can put the values here. AOL is 40. Now before putting this value here, you have to convert this into numbers. Okay, so AOL is 40 dB. Okay, that means you have to put a number. dB means this is a 20 log 10 of AOL is 40 dB. Okay, this is in dB. So AOL will be how much? dB cancel
100.
100. Log
Yes.
10 AOL is, this will become 2 and this will become AOL become 100. Okay, so now you can solve this one. 100 1 plus this is 100 and beta is 1 by 40. This become 100 upon 0 0. This is 5 by 2. Okay, how much come? 7. 7 by 200 by 7. Okay, how much come this one? Tell me. Around something 20.
28.57.
57. Okay, this is a number. Again, you have to convert into this number into dB. So in dB, so closed loop gain in dB will be 20 log 10 closed loop this number 28.57, and if you solve this one, this will almost will come 29. You solve this one, C, this will come almost 29 dB. Now let us do it. The question number 9. Okay. Question number 9. Which of the following, okay, in one of the following circuits, negative feedback does not operate for a negative input? In one of the following circuit, negative feedback does not operate for a negative input. Which one is in the op amps running supply is plus minus 15 volt? Okay, so which will not work for a negative input? Which circuit will not work for a negative input? Is the inverting configuration. So A will be correct. What is A? This is A is minus plus. You have some resistance here, and if I apply some negative voltage here, say -5, okay, some ratio is there. So obviously you will get some V naught equal to positive, some positive value. Okay, so this is, so here negative feedback is working. And similarly, if I replace option B, if I replace by a Zener diode, okay. So and applying, if I'm applying negative voltage here, voltage will come positive. So this is a positive negative. So this is also conducting. This is also conducting. Okay, if the sufficient voltage is there, so this option B is also correct. Okay. Option C, tell me option, if it is a normal diode, option C, tell me what will happen. If this is a, so here
It will become open.
it will become open because it's a positive, it will become open. So this here negative feedback is in C option is not working. So C should be correct. D is correct. D is it is working. At least one of the diode will conduct. So D is working. Open loop is present. Only here C option it is open. C is the correct answer. Okay. Tell me the next question. What should I do? So all are looking same similar line. कौन सा क्वेश्चन करना है अभी? 10, 11, 12 तो क्लास में कराया हुआ है, 13 भी अभी कराया, सेम ही है. बताइए कौन सा करें, और सारे करने हैं. So I think question 10, 11, these all are simple. 11, let us try 11. Okay, let us try 11. Here you have okay, this is your ground R1, R2, and this is RL. Okay, R1, R2, RL, and R1 is 5 kilo ohm. Okay, R2 is 1 kilo ohm, and RL is 100 kilo ohm. क्वेश्चन में क्या पूछा है? Find the current through R2. What is the current in R2? And this is how much is given? B कितना दे रखा है? What is the value of B? बताओ.
10 millivolts.
10 millivolts है. 10 millivolt है. बताओ कितना आएगा वैल्यू? तो आसान क्वेश्चन है. गौतम, किरण, कितना आएगा बताओ? श्रेया,
10 microampere.
10 माइक्रो एम्पियर. ओके, तो कैसे 10 आएगा? ये आपका 10 मिलीवोल्ट है, ये भी 10 मिलीवोल्ट हो गया, ये भी 10 मिलीवोल्ट हो गया. तो ये रेशियो करंट कितना आएगा? करंट इन IR2 10 मिलीवोल्ट डिवाइड बाय R2 कितना है? 1 किलो ओम. तो कितना आएगा? 10 माइक्रो एम्पियर.
Sir, can you explain the 10th question?
Which one?
10, sir.
10, okay. Oh. 10 is simple voltage dividers. You have plus, minus. Here you have a V input.
Sir, I'm getting confused with the options. I don't get what the options mean.
So this is you have a RL. Okay. This is 9 kilo ohm. This is 1 kilo ohm. Okay, V naught. So in the given circuit, the open loop gain is given, and it's power the feedback configuration and the closed loop gain. Closed loop gain are asking, they are asking closed loop gain. So this is basically non-inverting amplifier. Okay, non-inverting amplifier, and it's ideal. Of course, 10 to the power A is 10 to the power 5, so it's almost close to ideal. So the closed loop gain they are writing by AF. AF will be how much? 1 plus RF. This is RF by R. This is 1 plus 9 divided by 1, that is coulomb cancel.
10.
Okay, 10. 1 by number is number only, so it will come 10. 10 is the answer. Okay.
So what about the feedback configuration? What should we say?
So is AF is 9 is wrong. Series, shunt. Okay. So it is series shunt.
So what does it mean, sir?
See, series shunt means the voltage is getting divided in series. This voltage coming, okay. The fraction of this one coming as a shunt to the input, non-inverting as shunt, okay. And this voltage is getting divided as a series. So this combination is basically is called shunt series. इसको बोलते हैं shunt series. There are different type of feedbacks. Okay, you go to your material. Okay, there are 4 or 5 types of 4 types of different type of feedbacks given. How to differentiate which feedback is bit. So this is the voltage division. There are sometimes current will go from output to input. So based on there are different kinds of feedback. Okay, so this feedback is called shunt series feedback. You can check the different types of feedback in Google, then you understand. So this is the shunt series type of feedback.
Then how the series will look like?
Series cannot be there, na? Here current cannot go series to series because this current going through shunt only.
Okay.
Sir, RL is a shunt here.
Huh?
RL is shunt.
So from RL to whatever voltage is RL, that is getting divided in series, na? That is the shunt series. Okay. Okay, I'll send some video. Different types of feedback. Okay, I'll send on video, then you understand. Okay. Now next question, tell me what is next question. 11 is we're done. 12 is what is the answer in 12? Tell me. What is in 12?
150 D.
150. Ivandra, tell me how much will come? Question number 12. 100. कितना आएगा अभी? Ayan. Question number 12.
It will be 15 volt because we input.
Because
It is VCC is plus 15 volt.
yes. So your voltage cannot go beyond VCC. So if it is output is coming through resistance coming 150, it cannot go 150. It will saturate to minus 15 only. Okay, there's a negative inverting configuration, so it should come minus 15 only. But because they are only asking the magnitude, so magnitude will be only 15. So option C will be correct. Okay. Tell me option question number 13. 13 is same. What is the option 13? Just now we done some question, so you can do it. Question number 13 and question number 8. 8 not 8. Question number 6 is almost same. Okay, so that you can do it. Question number 14. Tell me. Question number 14. The input given to the ideal op-amp in a circuit is the correct output of the indicator circuit is there. Indicator circuit is there. You're applying V naught, and this one T naught. Okay. Can you tell me what is the correct option for this one? Indicator. This is the input for indicator, what is the output? Tell me. If this is the constant. I'm giving a constant V naught. Then what will be
Option A.
option A? Because it will be keep on increasing. Just now we are on caution. It will linearly increase if it is a V naught. Okay, at T0, after T0 it will be constantly increasing. So this is the option number A. Question number 15. Question number 15. Question 15 says, consider the circuit, differentiator circuit shown in the figure where RC equal to 1 for an input signal. For input signal shown below, choose the correct output waveform. Okay, so you have a differentiator circuit, minus plus. This is a differentiator circuit. Here you are applying V input, RC value is given 1. Okay, and the input is given this one. This is the input. This is the input. This is 3. This is 1. This is 1. And this is V input. 3, 2, 0. And this is T. RC value is 1. Find the output. Tell me how to do this problem. What is the output? What is the output equation? Output equation is how much?
Minus R.
Minus RC dV
Okay.
dVi by dt.
Minus RC dV by dt, V input by dt. Okay, you can easily find here this one, and 0 minus V naught. And RC value is given 1. So V naught will be only minus differentiation of this one. Okay. Now you have time period. You can write, you differentiate V input. So what is V input? You can write in the time period and in the functional form. Here slope is how much? What is the value here? 0 to 1. What is slope? 0 to 1 only, na? Yes, 0 to 1 only. So 0 to 1. So this is simply V input equals to T. For this, I can write this equation 1T. Yes or no? And
Yes,
for
sir.
next one, the slope is negative, slope is same. Same time period is coming 1 to 2, difference is same. So slope is negative minus T plus, what should I write?
2.
2. Let us check. This is T equal to 0 to 1, and it's from 1 to time period is 2 seconds. If I write 2 here, it becomes 0. If I write 1, if I write here 1 second, then this is 1. Okay, so this equation is correct. Now just you have to differentiate. So my V naught will be minus dt 1 minus 1 in this time period, and this will become plus minus plus 1 from 1 to T plus 2. So let us draw the output. First it will be minus, and then it will be plus, then it again the minus. Answer क्या आ रहा है?
Option B.
B and minus. So option B should be the correct answer. Okay. Minus V. Let me check. Question number is 15. Question number 15. Option B is correct. Tell me question number 16. Question number 16. Question number 16 में you're given one op-amp is a minus plus. भी मटेरियल में कुछ क्वेश्चन गलत भी हो सकते हैं. ओके, ऑप्शंस, solutions. Okay, so that is you have to check this one. 20 kilo ohm, and this is your V output, and here you are applying a sine input. Tell me which is the option correct. So V input is 1.5 sine 20 pi t in volts, and the saturation voltage is plus minus 10. Plus minus 10. Okay. बताओ भाई क्या ऑप्शन आएगा?
Sir, is it A?
Okay. So we are applying, say here the voltage is minus 10 to plus 10. Okay. And this is the example of positive feedback. This is a positive feedback. So output can be only V output can be only plus 10 volt to plus element, or it can be minus 10 volt. Okay. So if I assume it's initially plus 10 volt, then here some positive voltage will come. How much will come? Tell me. If this is a 10 volt, how much voltage will come here? So voltage across here, so I say B plus. So B plus will be how much? That will be 10 divided by 22.2 kilo ohm into 2.2 kilo ohm. So 10. How much is coming? Tell me. This is how much become? 22. 22. And this become how much? 22.2. So approximately it is 1 volt. Yes or no? Okay, some 9 volt something. So say approximately is 1 volt. So here voltage is 1 volt, and here this V input is peak value is 1.5. Okay. So initially for some time, if I plot the input, this is my input. Input is a sine wave of 1.5 amplitude, and I want to plot the output. So output here V plus is 1 volt. So 1 volt. So here potential will take place. So up to here, this voltage is less than this volt. Okay. So output will come positive or negative? Positive. So up to this period, because V plus is greater than V minus, so you'll get a positive saturation. And after this point to which point? Always. After this point, here you have negative is more. Okay. Then tell me after that. Here, after that it will be always positive. After that it will be always positive, because here this is a plus is more. Here negative is more. Up to here negative is more. Here positive is more. Okay. And here this negative become negative. So positive minus negative become positive. So this is always will come like this up to here. Up to here will come positive. Up to here will come positive.
Sir,
Hmm.
Once the waveform is higher than 1 volt, then the V out should be 1, right? It will be minus VCC.
Plus VCC. See, initially this is greater than this one, so this will come 10 volt. Okay.
Mm.
And after that, here this is in this part, this is greater than this one. So it should come minus 10 volts. Minus 10 volts coming here.
Sir, I'm just talking about the duration. The range should be same in both cases, right? Below 0 also we have a 1 volt, isn't it?
Just let I'm checking now. So now tell me what will happen. This is 1 volt. Now if you're applying some here already some 1 volt is there. Okay. Now for you to see minus BCC also, na? Okay, correct. We have to two points. Just correct. We have to find two turning points, na? So one turning point already I have drawn. This is the 1 volt, okay? And similarly, if V output is minus, so there will be one more turning point at minus this one, minus also. Minus 1 volt, correct. So now it's correct. So initially you will plus, from here to here, it will be negative. And then again here from here to here, and then here to here, it's a positive. Okay, and then from here to here
Sir,
negative.
it
Now
will be still negative there, right? In that short range.
why?
It remains negative because our voltage have to reach until 1, then only it will change, right? Because we already have minus 1 at this terminal.
So here it is correct. Up to here it is correct. Okay. Now next transition will take place when? Next transition will take place from here. So transition will take place here and here. Next transition will take place up to here. Correct. Up to here. So here to here it will come like this. Then next transition will take place here. So here to here. Okay. Now it's correct.
Yes, sir.
So you have to remember the hysteresis loop. Okay. You have to remember the hysteresis loop. 1 volt and minus 1 volt. Okay. So if it is plus, it will remain plus up to 1 volt, and this will come down here. And then if you want to go up, so it will go to minus 1 volt only. Okay. So if you want to go up again, you have to come up to minus 1 volt. Like this, you can remember. Shall I go to the next question? What is the next question? For a transistor amplifier, the frequency response to such that the mid-range voltage gain is 200. The cutoff frequency is 20. What are the ratio of the voltage gain at 10 hertz and 100 kilowatts? Okay. So basically, what they have given you filter, which is the mid-gain frequency filter. Mid-gain frequency filter means it is giving some. This is a basically band pass filter. You have been given a band pass filter. Okay, there's a gain A, and a gain is here 100. And what is the frequency range? Tell me, what is the frequency range here? Frequency range is
20
hertz
hertz to 20 kilohertz.
So this is 20 hertz, the limit, and this is 20 kilohertz. Okay. So above this one is this is a low pass filter. Okay, and this is a high pass filter. High pass filter will remove the frequencies before this one and pass after that this one. Similarly, your high pass filter, low pass filter will pass the frequency up to this one, and it will go this one. Okay. So now if I want to write, so this is your high pass filter. Okay. So high pass filter formula, what will be the high pass filter formula? Tell me. Gain of high pass will be, tell me, gain. What is the formula for high pass filter? Tell me.
A infinity by 1 plus
Hmm?
HC by
So A0 under root 1 plus high pass F upon FL square. Okay. If anything less than this one, I will use this formula. Is high pass. Correct? Yes or no? And this gain is A naught. This A naught is 100. If F is infinite, no,
Sir, FL upon F.
no, FL upon F. FL upon F square. If it is 0, then it's become infinite and this becomes 0. Correct. So this is high pass or low pass? If for high, this will be infinite. So high is passing. Correct. This is high pass. Similarly, for low pass, I can write A naught. This value is A naught, and then it is decreasing with frequency. Then this will be F upon FL square. If it is infinite, this whole becomes 0. So it's all becoming 0. Okay. Now you have the two formulas and you want to find the frequency ratios 10 hertz to 100 kilohertz. Okay. So for 10 hertz, you can use this formula, and for 100 hertz, 100 kilohertz, you can use this formula. Find the ratio, put the values and find the ratio. Cutoff frequency, you know, and tell me what is the ratio. So 10 hertz to 10 kilohertz, here gain. So gain at 10 hertz will be 100 upon 1 plus FL is 20. So this become 4. 4. 2 by 2, 20 by 2, 4. So this is 100 by root 5. Similarly, gain at 100 kilohertz. 100 kilohertz will be 100 upon 1 plus, this is 20, 105, 25, 25, 100 upon root 26. Okay. Find the ratio.
It's 200, right? The gain.
Hmm?
The mid voltage gain is 200.
200. Okay. Make it 200. 200. That will cancel out actually. 200. Now ratio 10 to this ratio you want. Okay. So this ratio will come how much? 26 by 5 required ratio. And that will be the answer. You can do it. Question number is 17. 2.28. Answer is coming. Let's check. So obviously this will come some 5 point something. This will come some 5 and this will be some 2.2. Some 2.28. Correct. This will be correct only. You can check it. Next question. Shall we go to next question? Is this question is clear to everyone? Saina, Rutu, Preeti. Shall I explain this question or it is clear?
It's clear, sir.
So next question is, the band pass and band reject filter can be implementing by the combining two low pass and high pass filters. Okay. So cutoff frequency of high pass and low pass filters are given. Okay. So you want to make a band pass and band reject filter. This question already we have discussed in the class now. If you want to make a band pass, just now what we have done. Okay, अभी भी question किया ना band pass का. So this was high pass. This was high pass, this was high pass, and this was for low pass. Low pass. So this is a band pass. So for band pass, V naught high pass should be less than V naught of low pass. Okay. And similarly, if I want a band reject, so band reject will be like this. So this is basically you are passing low frequency. So this will be omega low, omega 0 low pass, and it's passing high frequency. So this will be omega high pass. So this is for band. So this is for band pass, and omega naught LP is less than omega naught high pass for band reject. कौन सा ऑप्शन सही है? Which is the correct option? Abida, tell me. High pass is less than low pass, and high pass is greater than low pass. Option B. लिप्सा कौन सा सही है?
Option B.
B है ना?
Yes, sir.
Question number 18. B है. Okay. So question number 19. Okay, we'll do now question number 19. Question number 19 says the input to a lock-in amplifier has the form VIT. VI sine omega t plus theta I. Okay. The amplitude is the frequency phase input. This is the input signal. Okay. And then here given you multiplied by a reference signal. So you have a reference signal. Reference signal is what? Reference signal is the same, should be same in the frequency. Okay. The signal is multiplied by a reference signal of same frequency, amplitude and phase theta r. Okay. So amplitude is VR, frequency is same, the phase is theta r. Okay. This is given to you. And now this is fed to a low pass filter of cutoff frequency omega. Then the final output of the signal should be. Okay. So basically, this is a lock-in amplifier. Lock-in amplifier is used for to detect. Okay, what is the use of lock-in amplifier? So lock-in amplifier in laboratory, this is used to detect small signals. Okay, this is used for to detect small signals. Okay, like in millivolt, microvolt. If there is so much noise in the background. Okay, so say if you have a very small signal, this can be detected by amplifier. Okay, this input lock amplifier. Now suppose here so much noise is there. Say so much noise is there in the signal. So even though from this noise, it can tell you what is it can separate out this small signal. This signal. Okay, you cannot judge what is there inside. It's so much noise is there, but there is a small signal is there, which is varying with frequency. That lock-in amplifier can tell you while it's a measurement, sometimes noise is very high, especially when we are doing measurement in nanoelectronics. No? So your output voltage or the signal will be in microvolt and milli or microvolt and nanovolts. So that experiment is done in using lock-in amplifier. So now, so what does lock-in amplifier do? this is your input this one, and this is your reference. It will multiply, it will mix this both signals. Okay, so the output signal will be multiplication of this one. So multiplication of this one will be, tell me what it will be. Multiplication of this one too will be Vi. This is a mixed signal. I'll say this Vm mix. So Vi, Vr, and this is sine omega t plus theta I, and again sine omega t plus theta r. Okay. Now this is sine A, sine B type of equation. I can multiply by divide by half and multiply by 2. So this become 2 sine omega t plus theta I, okay, into sine omega t plus theta r. Okay. Now this is 2 sine A, 2 sine B. What is the formula for 2 sine A, sine B? 2 sine A, sine B. Formula is, tell me what is the formula? Cos A minus B, minus or plus?
Minus
Minus cos
A
I
plus
might
B.
A plus B. Okay, I don't know formula. You just remember, you tell
divide
me.
by.
Divide by?
No, sir. There is 2, right?
Ah.
So
So this formula I can write directly like this. So Vi, Vr, okay. This formula will become cos of A. So theta minus theta r, okay. And minus is there. Okay, I don't know. Okay, minus is there, na? Minus there, and then this is cos 2 omega t plus theta I plus theta r. So this is my mixed signal. Okay, this is my mixed signal. Now the multiplied signal is fed to a low pass filter to cut off frequency omega. Okay, so this signal has a frequency omega. What is the signal? What is the frequency of this signal? This is a DC, no frequency. So if I pass this output by a low pass filter of cutoff frequency omega, which is equal to this one, and here frequency is 2 omega. Here frequency is 2 omega. So obviously this part will be eliminated, because this part is a cutoff frequency is greater than omega, 2 omega. So this part, when I pass this for lower filter, my output will only come half Vi Vr cos theta I minus theta r. This should be the option. So option A should be the correct for question number 19. Okay, so it's correct. Now let us do the question number 20. Is this is clear to everyone?
सर ये लास्ट स्टेप में आपने क्या किया था इसमें?
ये यहाँ तक समझ में आ गया?
यस सर, फॉर्मूला लगाया फिर वो वैल्यू ले आए.
अब ये इसको लो पास फिल्टर से पास किया. इससे कट ऑफ
Yes,
फ्रीक्वेंसी क्या है? ओमेगा. तो ये क्या करेगा? ओमेगा से ऊपर का जितना भी, इट विल पास ओनली लो फ्रीक्वेंसी ऑफ ओमेगा. एवरीथिंग
sir.
एनीथिंग इज ग्रेटर देन दिस वन, इट विल रिमूव. इसका इस पार्ट का फ्रीक्वेंसी कितना है?
2 ओमेगा.
ये पूरा पार्ट रिमूव हो जाएगा ना. ये मल्टीप्लाइड बाय दिस
Okay.
पार्ट, सिग्नल विल बी रिमूव्ड.
Yes. Thank you, sir.
Question number 20. Consider a low pass and high pass filter with a cutoff frequency FLP and FHP. Here is a parallel condition for A and B. Okay. Which is the following signal is correct? ये तो अभी भी किया ही था हम लोगों ने. This is your high pass filter. high pass filter FHP. I'm giving an input, and then this is a low pass FLP. Okay, and this is your output. Tell me, कौन सा ऑप्शन करेक्ट है बताओ? Which option is correct? So this is ये कौन सा फिल्टर है बताओ? अभी भी किया था अपमा, tell me.
Pass.
ये this combined filter is what called what? And this is one more filter. This is your FHP and this is your LP, and here I'm giving you input, and here I'm taking the output.
Sir, band pass and band reject.
Yes, this is the band pass. This is the band pass.
Yes, sir.
And this one?
Band reject.
How? Band reject also was in the series. Only frequencies was changed.
Okay.
Tell anyone if you have done the class. Priti, Pragya, Lipsa, ये क्या हो जाएगा? What is this one? Tell me. अरे भाई,
It's band reject only, right?
how can be high pass? It is passing. Low pass. This is passing. Band reject only. Okay. So if they are given any relation in the FHP and FLP, just like let me check. FHP and FLP.
FHP is less than FLP.
Okay, FHP and FLP. Okay. Now this is band pass. Okay. So here high pass. So this is high pass. This is high pass, and this is a low pass. Okay. So here what is there? FLP is FHP is less than FLP. Okay. Here high pass. Anything is which is less than higher than FHP will pass. Okay. So say this will pass here. And it's FLP, anything less than FLP. FLP means less than that one, so that will pass. This is FLP and this is FHP, correct. If this is a common, if this become common, then becomes all pass filter. Okay, so now it says FHP less than FFP act as the band pass filter, and B HP. Which option correct? Tell me which option correct now. What is options correct?
Option A.
Option say B, FHP is less than FFP act as a band pass filter. Okay, but here this relation is not true, na? Here FLP is less than FHP, so this option A is not correct. Okay, FHP is greater than FLP. Stop signal. No, FHP is less than FLP. If FHP is less than FLP. Okay, so let us check this one also. So if I say now option C is FHP is less than FHP is less than FLP, band pass filter, this is correct. And a signal without filtering. Question 20 में क्या आंसर आना चाहिए? Question 20. What is the answer? Can anyone tell me what is the answer in question 20? C. They say option C is the correct. FHP is acting as a band pass filter. That is FHP is this is a filter. And B passes the signal without filtering. Without filtering. That means all the signal should pass. How?
For this condition, it will, right, sir?
Hmm?
Means when FHP is less than FLP,
Hmm. So if I
then
say, correct. FHP is less than FLP. For this condition, this is a band pass filter, correct? This is a band pass filter. Okay, and for that one, how can I say that is also all pass filter, right? This is say FHP and this is FLP, and you are passing a input here. Okay, now if I say my FHP is less than, so say this FHP is this one, this all signal this is passing from here, all signal is passing. Now FLP, which is greater than FHP, FLP, which is greater than this one, all signal of this one passing like this. Even the all signals less than FLP will pass. So this all signal, so now this all signal will pass. This will pass all this signal, and this will pass all this signal. So this is a no loss filter. This is all pass filter. Okay, is it correct?
Yes,
shall I,
sir.
or shall I explain again? Preeti,
sir, then
Sir.
there is no definite form of low pass and band pass, right? Depending on the frequency, we can use any of the
yes.
circuit.
You have to see the frequencies things. Okay, if there is a gap, then this will become band reject. Same circuit, same parallel circuit will become band reject, but there is no
But
gap.
if LP is less than HP,
Uh-huh.
then it will become band
Yes.
reject.
Yes, if LP is greater than FHP, then it will become band reject. Okay, so accordingly you have to check. Okay, so we'll give the break for 5 minutes. Okay, we'll meet after 5 minutes. So I'll come at 9:05. See, in this sheet, what I'm doing in the questions, here filter questions are not there. Filter questions. So filter questions may be in the GATE and TFIR. Okay. So please do those questions also. Question number, all are here. Question number 21. So if you see the question number 21, you have a R, and then you have a R here. ये यहाँ से कनेक्ट हो गया, तो यहाँ पे एक R और दे दिया है, and then you have been given a C here, and this is coming as a op-amp input. ये सारे माइनस प्लस हैं, तो बताया नहीं है कुछ, हम तो माइनस प्लस मान लेते हैं, माइनस प्लस, एंड दिस इज, अरे भाई विचारधारा बाद में देखना मैच का, ये पॉलिटिक्स, एंड दिस इज आर, and this is your C1 input, okay, and this is C2, and this is your RF, and this is your R1. Okay, this question number is 21. This is in the circuit diagram of band pass filter, band pass filter है, okay, high pass and low pass, okay, shown below R equal to 10 kilo ohm. In order to get a lower cutoff frequency of 150 hertz and upper cutoff frequency of 10 kilohertz, the appropriate value of C1, C2 you have to find respectively. Okay, you have to find the value of C1, C2. So tell me, first of all, whether this op-amp is a high pass or low pass. Tell me.
लो पास
लो पास, वेरी गुड. और कौन बताएगा कैसे लो पास है? प्रज्ञा, टेल मी, दिस इज a low pass or high pass?
Sir, it's high pass.
So you just have to check. Agar if I apply high frequency here, this will become short, so all voltage will come here, that will get amplified. If I apply low frequency, this will become open, and once this becomes open, this will become zero, so it will become zero. So this is a high pass filter. This cannot pass low frequency. Similarly, if some signal is coming here, if it is a high pass, this becomes zero, short. So B plus becomes zero. So this cannot pass high frequency. If low frequency, this becomes open. So whatever is here, it will pass here. So this is the basically low pass filter. Okay. Now what is the cutoff frequency for high pass filter? Cutoff frequency for high pass, say FHP, FCHP, cutoff frequency, or I say FC1. This is C1, C2, no? So FC1. How much is the frequency? Tell me. Cutoff frequency 1/2 pi R. This R C1. And for here, cutoff frequency FC2 is 1/2 pi R C2. Okay. Now high pass frequency and cutoff frequency is given. Lower cutoff frequency is 150 hertz, and this is a, for high pass, this is 10 kilohertz. This is a 10 kilohertz. Okay, 10 to 10 to the power 4, 10 to 10 to the power 3, 2 pi R C1, and this is your 150 2 pi R C2. Tell me what is the value of C1, C2? R value is 10 kilo ohm. R value is 10 kilo ohm. What is the value of C1 and C2? So C1 will be 2 into 3.14. R is 10 kilo ohm. And this is also 10. 10 to 10 to the power 3. Okay. तो कितना हो गया ये? 4 4 4 4 10 to the power 8. Okay, 10 to the power 8 minus 8. If I multiply by 10, this becomes 10 to the power minus 10 into 10 divided by 6.28. Tell me how much will come? 10 divided by 6.28, how much? Tell me which option is correct hand
So
side.
this 10 into 10 raised to 3 should be the frequency for the low pass, right?
So
It should be
no,
C2.
no. Is high pass filter, high pass frequency is given how much?
It's not the high pass, right? We have to make a band pass, isn't it?
Yes. So you know to get the lower cutoff frequency. Lower cutoff frequency is 1.5. Lower cutoff frequency 1.5 pass. So above this one, okay, correct. So this will become now lower cutoff frequency. No? This is band pass filter. So what is the value? Tell me. So this is 1 upon 2 pi. Here I should use 150, na? 150 hertz, and here 10 kilohertz. क्या आ रहा है आंसर बताओ? तो आंसर क्या आ रहा है दोनों का सॉल्व करके? 152.10. Yes, band pass. And is the angular frequency? They are asking angular frequency. Or they are asking cutoff linear frequency. बताओ अभी क्या आंसर है? Question number 21. Sign R. What is the answer? What is C1? आ रहा है कि नहीं आ रहा आंसर बताओ पहले तो.
Sir, 0.106 microfarad.
Option A or B, A or C?
Sir, A.
Second is coming 1.
Option A.
Option A, okay. So 0.1 microfarad and 1.5 nanofarad is correct. Okay. ठीक. Question number 22 बताओ कैसे करेंगे? Question number 22 is again like multiplier and low pass filter lock in amplifier. तो अभी भी किया ही था. बताओ question 22 का आंसर क्या आएगा? What is question 22? Question 22. Again a multiplier or mixer. You have a multiplier. Your coming V input is equal to 5 cos 100t. And here V reference, V2 which is V reference, a different magnitude and different phase, 100t plus pi by 3. frequency is same. Okay, I am passing by a low pass filter of frequency 5 hertz. That is important. You have to check this one. Okay, tell me B output.
There is 50.
So signal will be how much? Signal will be 100 multiply cos 100t into cos 100t plus pi by 3. Okay, again multiply by 2 and divide by 2. So this become 1 by 200 and 2 if you take here. So this become how much? Cos a minus b. Okay, so cos a minus b. So cos a minus b 100t this one. So cos minus pi by 3 is cos pi by 3. Okay, cos pi by 3 plus cos a plus b cos 200t plus pi by 3. So obviously this frequency is 5 hertz. So this will not pass. So only this will pass. So 120 100 cos pi by 3 is how much? Tell me.
1/2.
नहीं cos pi by 3 का वैल्यू क्या होता है 60 ना cos 60 is how much
1 by 2.
1 by 2. So this is 50 divided by 25. 25 option में है क्या 25? Okay, so option B should be correct. Question number 23 also same. Question 23 is also like a mixer. Question 23 says two signals A1 sin omega t, A1 sin omega t and A2 cos omega t, A2 cos omega t are fed into the input signal and the reference channel respectively a locking amplifier. The amplitude of the signal is 1 volt. The time constant of the locking amplifier is such that any signal of frequency larger than omega is filtered out. Okay, so low pass filter of omega, the output of the lock and amplifier is there. Tell me what is the output of this question. So how can you write this one? One is sine, one is cos. So either bring it in the sine form or you just multiply. So if you multiply, this will become A1 A2 sine omega t cos omega t. Okay, and if I write multiply by 2 and divide by 2, so this is 1 by 2 A1 A2 2 sine omega t cos omega t. What is the formula for this one? Two sine A sine B. This is what? This will be 1 upon A1 A2 sine 2 omega t. Yes or no?
Yes, sir.
अब frequency, this is the greater than omega. Okay, low pass filter is omega. So anything which is greater than omega, okay, will be phase out. So the cutoff frequency low pass filter, it will pass only up to frequency. So this is all a higher. This all signal is high. So output will come 0. Okay, so output will come 0. Option D is correct. Okay. Ritu, chale aage. It is clear. So you have to stall like this only. Sharlin.
Yes, sir, it's clear.
Okay, next question बताओ क्या है? What is the next question? Next question is a RC network produces phase shift of 30. How many such RC network should be cascade together to common emitter amplifier so that the final circuit behave like as an oscillator? Okay, so for common emitter amplifier, okay, you want the phase difference of 180. So here one RC is producing 30. So 6 into 130, 6 into 30, 180 should give me common emitter phase difference of 180. So option A will be 6, correct? 6 will be correct for this one.
So what does it mean by the final circuit behaves as an oscillator?
So basically we have to see this common emitter amplifier. Okay, so amplifier is working as oscillator. So I want to make to this transistor to work as a common emitter amplifier. Okay, so this should invert my phase first. Okay, then only it can work as an oscillator. So invert means it should have a phase difference of 180. So that is 30 180 divided by 36.
Sir, I didn't get it.
See, you want to make a, just now we have made an op-amp. Okay, we have not done the transistor, but we have done the op-amp as an oscillator. Na? It's continuously producing a square wave without any input. Okay, so that we are using in inverting configuration. Yes or no?
Yes, sir.
So inverting configuration means there should be phase difference of how much?
180.
180. 180. So here one RC section is producing the phase difference of 30. Okay. So if you give this RC as an input of as a transistor or anything, how many you require? 6, na? There should
Sir,
be.
I got that 180-degree phase shift part, but anyway, if you are connected it to a common emitter amplifier, it will also produce a 180-degree phase shift, right? The total, it will be 360 degree. So there
Right.
is no phase shift. Is that what we want?
No, it's for it has, if you want to, it has to work as an oscillator. The phase difference should be 180, not 360. Then only it can work as a oscillator. Otherwise it will
So
not.
here, if we have a RC network cascade, like if we use 6, there will be 180-degree phase shift. And again, common emitter will have a 180-degree, right?
No, not like that. Okay, you're saying that will add.
It is connected to common emitter amplifier, right? In the question, they are cascaded together and connected to common emitter amplifier.
That is correct. Yes, correct. So 180 plus 180 will become 360. Just 1 minute. A RC network produces a phase shift of 30. How many such RC networks should be cascaded together and connected to common emitter amplifiers so that the final circuit behave like a oscillator? Okay. So what should be the oscillator? How many the phase shift should be oscillator? Let me check. Phase shift for oscillator. Yes. For oscillator, the phase shift should be either 0 or 360. Okay. Now it's clear. For oscillator circuit, okay, the phase shift should be this is the circuit. Okay. This is your amplifier circuit. This is okay. And these are the sections. These are the sections. Okay. So this is called phase shift oscillator. So if you want the phase should be the 0, okay, this should be 180 and 180 should be 0. Okay. And in op-amp, what we've done when we are doing op-amp, that time what we have done, we have not done phase shift oscillator in op-amp. Na? We didn't do this one. We did not do this in the class actually. Phase shift oscillator. Let me check the answer. The total phase shift must be 30. Common emitter amplifier has a change of 1 process. Okay, correct.
Sir, we have not done this in the class, oscillator part.
Yes. Okay. मैं इसको वीडियो बना के भेजूंगा, टाइम मिलेगा तो अगर। ओके, चलो द नेक्स्ट क्वेश्चन। व्हाट इज द नेक्स्ट क्वेश्चन? Question number 25. Tell me it's a high pass or low pass filter. Directly you can check. Don't need to solve. बताओ भाई, is high pass or low pass?
Sir, high pass.
High pass है. Okay. It is high pass filter. Directly you can see, check. Okay. Question number 26. Question number 26 is there. This is your PN and this is your op amp is given here plus minus. This is your V2 and this is your V1. Okay, this is overpressure indicator, and this is your pressure ready indicator. Okay, and this is given you 500 ohm. So question says the pressure of the gas in the vessel needs to be maintained between 1.5 to 2.5 bar. Okay, so you want to mention pressure in the vessel. This is a vessel. The pressure should be 1.5 to 2.5. This is my limit. Okay, in experiment, the vessel is fitted with a pressure transducer that produces 4 milliampere to 20 milliampere current passing pressure from the range 1 to 5 bar. So I have a transducer which is produces current. Okay, if I apply this pressure for 1 bar, how much is producing current? 5 milliampere, and for 5 bar, it is producing 20 milliampere current. 20 milliampere current, and this is 5 milliampere current. Check करो सही कि नहीं है?
So 4 milliampere.
4 milliampere for 1 bar, and for 5 bar
20.
20. Okay, so this is the graph for this one. So for 1 bar, how much will produce? Tell me what is slope of this graph? Slope will be how much? Tell me. 20 minus 4, 16 milliamperes. 20 minus y2 minus y1, 20 minus 4 divided by 5 minus 1. That is 16 milliamps per 4 bar. That is 4 milliamps. Okay, for 1 bar. Can I say like this? Is milliampere bar 4 milliamp per bar. So now I want to produce 1.5 to 2.5 pressure. This is transducer. So I know this can produce for 4 milliampere. This can produce 1 bar. Now I want to produce 1.5 bar. So this should give how much current? 1.5 into 4 milliamps. That is how much? How much current should give? 4 milliamp. This will be 6 milliamp. So this should give 6 milliampere. If I want to measure this pressure, this one 1.5. Here the current should be 6 milliampere. And if I want to 2.5, then for 2.5 into 4 milliampere, there should be 10 milliamps current. Okay. Now, what is the voltages V1 and V2 value? Okay. So suppose I am sending this current 6 milliampere here, 6 milliampere here. Okay. So what is the voltage here? Tell me. 5 into 5, 500 into 6 milliampere, 500 into 6 milliampere. How much will come? How much will give me? 3000. So this will give me 3 volt. 3 volt. So this voltage will come 3 volt. If current is so So when this is indicated it is ready. So whenever current is here 6 milliampere, this become 3 volt. This V1. So here this is if I put this is 3 volt. So if I put this is 3 volt, okay, this will say my pressure is ready. Okay, if it is this is slightly greater than this the V1. If this voltage is slightly greater than V1, then I will say that this pressure is ready. So I want to say at 1.5. So for 1.5, this I should fix this is a 3 volt. And it is slightly greater than 1.5. This voltage will become slightly greater than 1.5, and this will say this is the pressure is ready. And when should I stop? I should not go beyond how much bar? 2.5 bar. So 2.5 bar. For 2.5 bar, current should be 10 milliampere. So 5 into this should be 5 volt. This should be 5 volt. So current can come from 6 milliampere to 10 milliampere. Then first it will say it is ready when the 1.5 bar is reached, and when 5 volt is come, it will say stop. The pressure range is crossed. So this range, this should be when V2 should be 3 volt and 5 volt. This should indicate. Tell me if it's not clear. I should explain.
Sir, can you explain once again?
Yeah. See, you want this op-amp to work as a pressure indicator. Okay. So this is a pressure ready. This is the overpressure indicator. So at the pressure range, I want pressure range is given for me is 1.5 to 2.5. Okay. So whenever this transducer has a pressure 1.5, how much current it will give? So it will give 6 milliampere current.
Okay.
Okay. So 6 milliampere current. So how much voltage will be there here? 3 volt. Okay. 3 volt. So this 3 volt. So I want to say this pressure is ready. So it's slightly it should be slightly 3 volt. This should say is ready. That means this voltage should be greater than 3 volt. So I will put V1 as 3 volt. So automatically this is slightly 3. This will say ready. And when this voltage become 10 volt, okay, or 5 volt, this will indicate. So this will already indicate it's ready, and now this will indicate overpressure. So that's why I note a range.
Sir, how we get the current here?
That is we should not go about that. That is a transducer, na? Okay. Depending on the that is device. So transducer is basically what? If you apply pressure, it will create the voltage. Okay. And if you create a voltage, if some resistance is there, circuit, it will flow the current. So that is given to us. Okay. How it is producing, that is here we don't.
Okay, not about producing. So we draw a graph between 1 to 5 using the range of this.
See, they already given some values, na? This 1.1. This is giving
for
this.
1 it will be 4, and for 5 it will be 20.
So I know by slope. Okay. So now for any bar, I can calculate how much approximately current will be there. 0 bar, there will be 0 current. Okay. So for 1.5 bar, how much current will be there? We are calculating, and then we are saying fixing this voltages.
And so we calculate the voltage by IR, right?
Yes. So here resistance is there. Okay, and this is giving current. This is giving current depending on the pressure. This device is giving current depending on the pressure.
Okay.
Okay. Now you should not bother about how direction of current. Okay, because that much information is not given here. So what we can do, we can only want that how it will indicate. Okay, that's this potential should be with respect to something. Okay, so I don't know whether the current is flowing inside or outside. That we don't know. Okay, we can whatever information given, based on that information we can only solve these things. Okay. Tell me the next question. Question number 27. Or which should I do? Now I'll do only 2 problems. Tell me, because we don't have time. Which problem should I solve?
30.
27, 28, 29 and 30. Tell me.
30, sir.
30 actually questions is wrong in the exam, this your notebook. So we already solved in the class. Let me do it. Here, this is 30. This is plus minus 10 volt plus 10 volt. Here it is V2. Here you have minus plus 10 volt minus 10 volt. This is V1. And here this is coming here a resistance.
सर 28 क्वेश्चन बता दीजिए.
और 28 बता देंगे इनको. और ये यहाँ से आके इधर जुड़ रहा है. And then this is come here. This is 5 kilo ohm, 500 ohm, 5 kilo ohm. Okay. And this is coming here minus plus 5 kilo ohm, 5 kilo ohm, and this is V0 plus minus. I already given the formula for this question. Simple formula. So this is like this, and this is coming from here to here. 5 kilo ohm, 5 kilo ohm, 5 kilo ohm. Tell me. So V1 is given 2.5 and V1 is given 2.5. This is 2.5 and this is given 2.25. 2.25. Okay. Now we have to solve. So it should come 11 times of this one difference. So I already told you here no current will go. Say some voltage is here V01. Some voltage output is here V02. Okay. So this V2 will come here. So this is V2. This V1 is come. So V1 will come here. And here no current will go. No current here. I minus is 0. I minus is 0. So here no current is going. So this current is going only here. So we can write V01 minus V02 divide by 505. How much? 500 ohm. So 10 kilo ohm, 0.5, 10.5 kilo ohm, 10.5 kilo ohm. Okay, that is equal to V2 minus V1. V2 minus V1 divided by
500.
0.5 kilo ohm. So this is cancelled out. Okay. Now tell me V2 minus V1 value is already given. Can you find what is V01 minus V02? Tell me what is the value? Okay, so you can find the value here. How much will come? This is 10.5 divided by 0.5. Okay, V2 minus V1 and this cancels. So this is how much? To 11. So this will come 11 V2 minus V1. Difference of V01 minus V02 is 11 V2 minus V1. Now similarly, if I want to find what is V0 here, so here this is V01 and this is here V02. Okay, I can now solve this for V0 by superposition principle. So superposition principle says V0 will be, this will be 0 and this is like this. So RF minus R1. So this become minus V01 RF upon R. Okay, and then plus, this is V plus 1 plus RF by R, that is 1 plus 5 by 5 R. V plus is how much? V plus is your V0 by 2. 2 cancel. So this is also V0 minus V01. V02 minus V01, and which is equal to what? 11 V2 minus V1. 11 What is the value V2 minus V1? Tell me. 2.25, 2.5 minus 2.25. What is the difference? 25 millivolt.
0.25.
Okay. 0.25 or 0.25. 0.25. So answer is how much? Tell me.
5.25.
5.25 volt is the answer. So in the material answer is given wrong, but if you check the correct sheet, answer sheet for just, this is given 5.25.
Sir, will you provide the solution after class?
Yeah, it's already in your material, na? But this will not be.
Okay.
So I will give you old solution only.
Sir,
Okay.
when we check the material, not all questions are there in the material, I think. For the
Okay.
transistor part, it was like that.
Okay. So I am sending the solution also. I'll give the solution also. Now, which question should do? 28 or 29?
28, sir.
28. This is minus plus. This is R. This is V input. R. R. And then you have a R grounded. And then you have a R. This is V naught R. So operation amplifier is given, VCC given, VCC 15 volt, R is 2.2 kilo ohm, V input is 2 millivolt. What is the value of V naught with respect to the ground? Okay, we need to find V naught. This is 15 volt is given. 15 volt is given, okay. And this is 2 millivolt. I want to find what is the V naught here. So obviously this is ground, so this is 0. I don't know this potential, say this is VA. Now some value is coming here, current is coming here. Say some current is going, some current is going like this. Okay. Now I can find what is VMI. First I will find by this equation I can write VI minus 0 divided by R is equal to 0 minus VA. Same current is coming here, R. So this will give me RR cancel. This will give me VA is equal to minus V input. This is the one thing. Okay. So VA is what? VA is minus 2 millivolt, minus 2 millivolts, so minus 2 millivolt. Now for second, I can also write here.
Sir,
Tell me.
that VA minus 0, there will be 2R, right?
Why 2R?
There are two resistance RR.
VI, this voltage
Okay,
is
that's
VI,
0. Okay.
0, and this current is going from here to here.
Okay.
Okay. Now for this node again, I want to find this VA. So some current is incoming current. I will take negative, outgoing current positive. Okay. I'll say this is I1. I say this is I2. I say this is I3. So incoming current is what? Incoming current negative. I'll take negative. Okay. So I'll take minus I1 plus I2 plus I3 equals to 0. Sum of currents 0. Okay. Or incoming current equal to outgoing current. So you can say I1 is equal to I2 plus I3. That you can take. And I1, you know, just now I written I1 is 0 minus VA upon R. And I2 is what? I2 is your VA minus 0 upon R. And I3 is your VA minus V naught upon R. Okay. R cancel. You can find now V naught. How much V naught? So minus VA plus VA plus VA minus V naught. So V naught is equal to 3 VA. Okay. And VA is equal to minus 2 millivolt. So it should come minus 6 millivolt. Is there any option? No? Check it, what a mistake I'm doing. VI is 2. This all are R. Check it. What is the mistake? So VI minus 0 upon R, 0 minus VA, VA minus VI. Okay. So this is 0 minus VA upon R is correct. And I2 is your VA minus 0. And is VA minus V naught is 0. Okay. So this is minus VA. And this is VA, 3 VA. This is correct. Okay. So answer may be wrong here in the question. Question number is 28. Let me check. Three millivolt. No. This is not this. This the solution is given. The manual is wrong. How can you remove this? R by 2. How can you do R by 2? You cannot do R by 2 this one. So what is in the question, in the solution, what they done? This and this they have made R by 2. You cannot do like this. Okay. So the options are wrong. The answer is 6 millivolt. This was 6 millivolt only. Any other question? Tell me. Shalin, is it okay?
Yes, sir.
So option may be wrong. See, sometimes questions come in the exam also wrong. Okay. So any other question I would do? Batao bhai. Priti. So let us do question number 29 because time is there. Question number 29. So question number 29. Analyzes the ideal op-amp circuit in the figure. Which one of the following statement is true about the output voltage V out when terminal C is connected to point A and then to point B? So we have op-amp. This is op-amp. Minus plus. You have R. And then you have this C. Okay, and this is your input you are giving here, and this is connected to here A, R, and point B. This point A, point B, and this is your R. And here you have a R also. And this is your V output. So if I connect this point to A, then what will become? Tell me. Then what should be the V output? So V output will be what? V output will be, if I'm connected this V input here, so here V input is coming here. Basically this become like this. There's a minus plus, and I'm giving, this is like this. Okay, output this input, V input is coming here. This is R, and here this V input also coming to minus also through this RFR. So the V output will be superposition principle minus RF upon R by R into V input plus here V input is there, V plus is also V input. So this will come 1 plus R by R into V input. So this is minus V input and this is plus 2V input. So this will come V input only. Okay. And second time when I connect it to this B, if I connect this to B, so B becomes 0. So this V plus becomes 0. So you have only V out will be only minus V input. So कौन सा सही है? So V out is equal to V input and V also minus P when C is connected to A and B. Option number A, question number 29. सही होगा तो question number 29. Option A is correct. Okay. So let me stop here. Now, if we have one more class, in that class we'll do this digital questions. So now I'm sending all the solutions to you. If you have any difficulty, you let me know. And some questions are not missing here for GATE and TFIR. Please try to do those also. So I'm sending the solution now.
So TFR questions are not in the booklet.
Yeah, but I have solved. You can see my video solutions. And if you have any question, you can send me. Okay. Offline, online. Okay, I'll stop here. Thank you.
Thank you, sir.
Thank you, sir.
Okay.
Thank you, sir.